Hello everyone. In this lecture, we will see how we can design a CMOS circuit to implement any Boolean function. And first example that we are taking is y is equals to a plus b c whole bar. So before starting this question, I am just clearing some basic idea about the CMOS circuit. To design a CMOS circuit, first we have to implement a PMOS circuit at the top. Then at the bottom, we have to design by using the NMOS circuit. At the top, we need to provide the VDD supply. And at the bottom, we need to connect to the ground, GND. And from the center, we can take the output. Another important point to note is what? In case of PMOS, to implement the functionality of an AND gate, the PMOS will be connected in parallel. Similarly, to implement the function of OR gate, the PMOS will be connected in series. Similarly, in case of NMOS, to implement the functionality of an AND gate, the NMOS will be connected in series. Similarly, to implement the function of OR gate, the NMOS will be connected in parallel. So this much basic idea we should have to implement any function by using the CMOS circuit. Let's see how we can implement y is equals to a plus bc whole bar. Another important point to note is what? In case of CMOS, it is already a complementary MOSFET. That means inversion is already there. Okay, complement will always be there with CMOS. We have to focus on A plus BC. Right. Now, as we know that for the AND operation, between B and C, for the AND operation, PMOS will be connected in parallel. Okay. So first I am implement this function by using the PMOS, and the B and C will be connected in parallel like this. Clear? So here I am connecting B and here I am connecting C. So now this BC is already implemented. After that, OR operation of BC with A. OR operation means a series combination, right? In PMOS, in case of PMOS, for OR operation, it should connected in the series. Okay, so how we can do that? We have to connect one PMOS like this, and here we will give the input A, and like this. At the top, we need to provide with a VDD. Okay, that means we have implement this functionality of A plus BC by using the PMOS. Now the same thing we have to do with NMOS, because as we discussed earlier also, at the top we have to implement by using PMOS, at the bottom we need to implement by the NMOS, and from the center we can take the output, right? So now here I am implementing and it's the connected one. Okay, so after this we need to implement by using the NMOS as B plus C. Okay, the same function A plus BC. So here you see dot operation. Dot operation in case of NMOS is a series combination. That means B and C will be connected in series like this. So this is B and this is C, because they are having the AND operation between them. Plus operation or the OR operation will be implemented in parallel. So now along with BC, you have to connect A in parallel to it, right? So this is A. Now this is the complete circuit for A plus BC by using the NMOS. From the center, we have to take the output. This is V out. And at the bottom, we need to connect to the ground, GND. So this is the complete circuit. If I show you in a single screen, then you can see at the top I have implemented by using the PMOS. This is PMOS. Similarly, I implemented the same function by using the NMOS. At the top, I have included VDD supply. At the bottom, I have given ground. And from the center, I am taking the V out. Clear? As it is a complementary MOSFET, bar will always already there. Right? Now you see another question. If you get a question like this, if you get a question like this, y is equals to a bar plus bc bar. Now, as I told you, and we have to implement this function by using the CMOS. As I told you, complement will always be there with the expression. It should be there with the expression. But in this expression, it's not there. So how we can include that? By including two bars at the top, because it will cancel. It will not change the functionality. And after that, we have to apply the De Morgan's theorem to implement this single bar. Okay, so now y, and you know the De Morgan's theorem. So this is a bar double bar dot b dot c bar whole bar, and this bar was there. That means I included one bar inside it. Now a dot b plus c, and this is bar. So now I have the bar over it. Now this expression is able and realizable by using the CMOS circuit, because as I told you, it's a complementary MOSFET. Bar should be there, as in the expression bar was not there. I included two bar, and then by using the De Morgan's theorem, I have opened the expression. Now I am getting a plus b bar, a dot b bar plus c whole bar. Now, as I told you, bar is already there. Now we have to focus to implement this a plus b, a bar, a dot b bar plus c by using the PMOS circuit, right? So how we can do that? See, plus, that means OR operation, that means a series combination. If I am talking about the PMOS, series combination of a b bar and c, right? Here I'm using the b bar. Okay, so here I can write down b bar. This is a c, right? This is c, correct? And after this, it's the AND operation. That means a will be connected in parallel, right? At the top, we have to connect to the VDD, and a will be connected in parallel like this. So this is what a. Now connect it like this. This is how we can implement a dot b bar plus c by using the PMOS, as this is a inverter, or PMOS is an inverter, so complement will always be there. Now at the bottom, we have to draw the same expression by using the NMOS, right? As this is a plus sign or expression, or expression means what? They should be connected in parallel. Okay, so now here I am connecting B bar and C in parallel. So this is B bar and this is the C. Similarly, dot, that means AND operation, that means A should be connected in series. So now here I am using the A. Connect it like this and connect it like this. So this is how we can implement by using the NMOS. From the center, you have to take the output. This is V out. At the bottom, you need to connect to the ground. This is okay. But if in the question they mention that B bar is not available, okay, how we can implement, how we can get this B bar? This is very important point. So if we don't have B bar as an input, how we can make this B bar? Now, as you know that PMOS is an inverter, right? If I will make it like this, and here I will provide B, right? From near to ground, this V out is equals to the B bar, right? And this is VDD, correct? So If I include it here, I will get B bar, correct? So same thing you have to do it here. You connect it like this. This is a B. If you provide B here, then this will be the B bar that we require actually, right? Similarly here also, for getting the B bar by using the NMOS, how we can do that? If you provide B here and this is VDD, near to VDD you will get the B bar. This is V out actually, and this is B bar because NMOS is also inverter, right? So same thing you have to do it here also. Now here if you provide B, from this side you will get the B bar, this is VDD, and this is the ground. Now this circuit is the complete circuit expression for this A plus A dot B bar plus C. Clear? We will solve some more question related to it. For example, in the next question we are taking, I have expression like Y is equals to A bar B bar plus C bar. For example, like this. Now you see, as I told you, it's a complementary MOSFET. The expression should have a complement with it, but it's not. So what we can do, you have to make two bars that will cancel the effect, and the expression will be similar to this one. After that, you apply the De Morgan's theorem here and open one bracket. So one bar you open it. So that will give you A plus B dot C. This is the expression. Let's see how we can implement this expression. Complement is already there, then not an issue. But how to implement by using CMOS? At the top, you have to implement by using the PMOS circuit. So as this is a plus sign or operation, A plus B will be connected in series, right? So I am connecting two PMOSes. This is A, this is B. That means it's a OR operation. Dot or AND operation, that means parallel. So parallel to it will be connected to a C. So this is B, this is C, right? So that means I implemented by using the PMOS. That's okay. After that, at the bottom, we need to implement by using the NMOS. As the expression is A plus B, that means A and B will be connected in parallel. So now I am connecting with in parallel. This is A and this is B. Dot operation or AND operation with C, that means it should be connected in series with it. So here I am connecting in series with it. This is C. This is the complete circuit. At the bottom, we need to connect to the ground. This is G and D. From the center, we have to take the output. This is V out. And this is the complete circuit implementation by using the CMOS. Again, next question we are taking here. For example, we have Y is equals to A bar B plus C whole bar. That's okay. As we require the any expression should have a complement, it's there. That means we have to focus only on A bar B plus C. Okay, so first I will implement this expression by using the PMOS, right? PMOS says that if they are connected in AND operation, that means parallel, right? So here I'm using A bar and B. So this is A bar and this is B, right? They are connected in parallel. Okay. Now plus C, that means it should be connected in series, right? OR operation means series. So this is C. At the top, you have to connect to the VDD. That means this is the circuit by using the PMOS completed. Now we have to implement by using the NMOS. NMOS says that if they are having the AND operation, they should connected in the series. That means we can connect it like this. This is the series operation of this is A bar and this is B, right? And plus or operation with C, that means it should connected in parallel. So this is C. At the bottom, you need to connect to the ground. Okay. From the center, we have to take the output. This is okay. But how we will get this A bar, right? And in the previous question also, I explained how we can get the A bar by using the PMOS. For that, you need to connect A here and VDD here. V out will give you the A bar in case of PMOS, because PMOS is an inverter. So same thing we have to do it here. I am connecting it like this. Here I will give A. This is VDD. At the bottom, I will get the V out, and V out is A bar actually. Similarly, to get the value of A bar by using NMOS, you have to connect it like this. This is A, for example. Then this V out is equals to A bar, and this is VDD, and this is the ground, right? So for getting the A bar, you need to connect near to VDD like this. Here you give A, this is VDD. This was the this PMOS, that's why bubble should be required. And now this is connected near to VDD, and this is ground GND. Clear? Now the last question based on the CMOS, and you see how we can solve this type of questions. So for example, in the fifth question, I am taking y is equals to A bar B plus B bar C whole bar. In this question, complement is there, that not a issue. If complement is not there, that means you have to apply double bar and apply the De Morgan's theorem. Okay, but as here in this question, complement is already there, so not a issue with us. And we have to implement this A bar B plus B bar C by using PMOS at the top and NMOS at the bottom, right? So as this is a bar dot B and operation between A bar and B, that means it should connected in parallel, and operation should be connected in parallel if you talk about the PMOS, right? So if this is PMOS, okay, this is A bar here, this is okay, this is A bar and this is B. Similarly, it should be connected in series with the parallel operation between this is B bar with C. Okay, so this is the implementation of this expression by using the PMOS. At the top, you need to connect to VDD. Now at the bottom, we have to implement the same expression, that is A bar B plus B bar C, by using the NMOS. So that means in this case, A bar B will be connected in series. A bar B will be connected in series. So this is A bar and this is B. Similarly here, this B bar and C will be connected in series. So this is B bar and this is C. Correct? Now you connect it like this. This should be connected to ground. That is okay. And from the center, we can take the output. That's also okay. But how we will get these bars? Okay, these bars are very important. This A bar and this B bar. How we will get this thing? Okay. So as you know that for getting the A bar by using the PMOS, it should be connected like this. Here you provide A. From near to bottom, you will get the A bar. This is VDD and this is ground. As we know that in PMOS, you will get, it will work as an inverter and the output will get at near to the ground like this. So here I will provide A. This is the ground, and from here you will get the A bar. VDD. Similarly, for B bar also, you have to connect it like this only. So here, this is PMOS, this is PMOS, this is B, and here you connect to the VDD. Here you will get the B bar, and this is the ground. So now PMOS is completed. Similarly, we have to do it for the NMOS. In the NMOS also, you will get the inversion output like this. This is, if you connect it A here, then near to VDD, you will get the A bar. This is the ground. Similarly, here, how we will do that? Here I will connect it like this. Here I will give A, and here I will get the A bar. Sorry, this will be at the top. So from near to the VDD, you have to connect it near to VDD. Similarly, for getting the B bar, you have to connect to near to VDD like this. This is VDD and this is the ground. Here I will give B, so you will get B bar. This is the complete implementation of this function by using the CMOS. That's all for this lecture.